Hello everyone and welcome to Jagasa's webinar Building Smarter Scorecards with AI and Synthetic Data. My name is Krishna Mehta and I am one of the co-founders at Jagasa. Today we will be sharing the results from our research and experiments on applying AI and synthetic data to different business applications, in particular credit risk. We are very excited by what we are seeing, and I hope you find these results useful as well. So let us begin by a quick overview. We will be focusing today on four key areas. Uh, First is how we can use these techniques to enhance the performance of our scorecard. Uh, the second is how do we reduce the bias, especially the implicit bias that creeps into the underwriting process. Uh, we will be talking about lowering the data acquisition costs using these techniques. And we will also demonstrate the applications around strengthening data privacy and security. In addition to these four topics, we will briefly touch upon model performance monitoring and validation. And we will not cover it in detail because we have an upcoming webinar on that. We will announce it shortly. It should be sometime later in the year. So let us start by talking about improving the scorecard performance. So the first thing in this area is that we can use large language models to improve scorecard performance. Let me tell you a little bit about the experiments we have been doing here. If you have been following us, you have probably seen some of our earlier webinars on this, but we experimented with models like DeepSeek, Llama 2, and other models as well, lightweight models like Finbert, Robota, and we have used these models to we have fed prompts to these models and generated embeddings. So a credit risk record was fed one record at a time, and we generated the vector embeddings from the large language model. Then these embeddings were extracted and fed to a traditional model like XGBoost or logistic regression, along with the other standard predictors we would put in a credit risk model. In other cases, we use the large language model and we fine-tuned it with local data within our servers and directly used it to do a credit risk prediction. And in both these instances, we found there was significant improvement in the model performance. Let me now take you through the results we obtained from our experiments with the large language models in terms of credit risk performance. So in this table, we summarize the results. Traditional model results you see here are using only the original features you would use in your general credit risk models. Traditional plus embeddings is when we take those traditional original features plus large language model generated embeddings which are added as additional predictors. And then transfer learning with large language model is essentially when we have fine-tuned the large language model directly and then used it to predict credit risk. In all these cases, you see the introduction of large language model into the modeling process had led to improvements in the model performance across all three samples. And that holds a lot of promise because even a small improvement can mean significant less credit failure and improvement to bottom line for an organization. Vision AI models use pictures instead of tabular data as inputs. And the area of computer vision is very important and significant part of artificial intelligence. And vision AI models can help with credit risk model performance as well in many ways. They have very interesting applications. The first way is you take the picture of your data and feed it to a vision AI model and generate embeddings. And these embeddings are then added alongside your traditional predictors, just like you would in the large language model example we talked about earlier. And then another application is more like an exploratory explanation. Vision models do a very good job of finding nonlinear relationships, much better than we can do with traditional exploratory analysis techniques we use. And that opens up very interesting feature engineering opportunities using which you can improve the quality of your credit risk model. And then there is the multimodal application where you directly feed the picture or into the model. uh, we are experimenting with that, and we will be sharing results around that. But applications of these could be like in mortgage, where you feed the properties picture, or in equipment finance, where you put in pictures about either applicants, offices, or the actual equipment being financed. Depending on the use case, what the pictures are could vary, but that could be very useful. Potentially this could be expanded even further, and we could also take in audio elements into our models. But right now we are working with including pictures into the actual model. uh, we are going to have a series of webinars on this over the next few months. We'll have two definitely on the different applications of vision AI models to analytics problems. The first one is scheduled for September 5th. So if this is of interest to you, please sign up for that event. Let me now talk to you about an area which at Jigyasa excites us more than any of the recent developments and their applications to credit risk. That is the use of synthetic data. Uh, I'm not going to go into synthetic data generation methods and tests around it, because we have uh, comprehensive webinar on that already available. You can check out our YouTube page, or you can reach out to me and I'll send you the links to that. Happy to share any additional information you need. But I'll focus right now on its application to credit risk. Now, um, synthetic data, one of the big uses is that it can help us model underrepresented or sparse groups which could otherwise not be available for modeling. And that leads to a more detailed and comprehensive credit risk program, which accounts for these underrepresented groups in a better way and ends up building a more robust model. Let me illustrate that with a simple example. Say you have your customer base, and the first thing you would do before building your credit risk scorecard is do some segmentation to decide how many segments you will bill with. And we all know that a good segmentation exercise can improve your model performance by 5 to 10%. So say you do run your segmentation algorithms, and it comes up with four possible segments. Now, that is the optimal solution. But as you notice, one of the segments is very small. And so in current situation, what is often done is we work with a three segment solution, and one of the smaller segments is combined with one of the larger segments. But what if we took that smaller segment and then generated some synthetic data for that segment, and then we are back to our four segment solution, and we are moving towards a more optimal result. But a fair question there would be, what about our performance? So let me share with you some results from these experiments we have conducted. So we took uh, a, a credit risk data set. In fact, it was a publicly available Australian credit card data. And we divided it into train, validation, and test, but also kept a holdout sample away from it. And this is the performance we got on the different samples. Then what we did is we used that data um, to generate um, some synthetic data using different techniques. We will not go into the details of the techniques, but the holdout sample was not used in the generation of the synthetic data, but the holdout sample was also used, the same holdout sample was used to validate the traditional model as well as the models generated using the different synthetic data techniques. Uh, the first result is for a technique called GREAT, which is based on large language models. Uh, then we have a synthetic data developed using real tab former, and then we have synthetic data developed using tab DTPM. All these different techniques give us very good results, and we have detailed results and explanation of these in our earlier YouTube presentation. But right now, the important thing to see is look at the holdout sample results, and they are so much in line with each other, which tells you that using synthetic data, you can duplicate the results you get with real data. And therefore, the example I showed you, where the model, we were able to get back to the optimal segmentation, uh, it becomes possible without compromising any model performance. Let us now talk about reducing the implicit bias that creeps into our credit risk process. So, the sources of bias in any credit risk scorecard implicitly often come in because we are using score cutoffs. And a lot of times, because of those cutoffs, we might see we have, without realizing it, excluded people maybe from certain geographical regions, or with certain demographic profiles, or business maturity, startups, emerging sectors, which have thin credit. Now, reducing bias matters. Why does it matter? There is the underlying thing about fairness. You want to reduce your credit risk, but you don't want to be unfair to anyone. The thing in addition to this is that your model must be robust. It must be able to take in turbulations and shocks, and a more varied credit pool improves the model's ability to do so. And the third thing is that there might be missed opportunities as well. Uh, for example, the emerging sectors of which will become powerhouses tomorrow, but might not fit your traditional definition of what is good credit right now and might get overlooked. Let me now talk to you a little bit about how synthetic data can help reduce this bias. So, you know, we when we use a credit model, we use cutoff score to make a selection. Now, because of this, a section of the universe gets rarely selected. And so any future model we build on the credit approved people will have an underrepresentation of this section. And this leads to bias in model performance because you're building a model on a sample that is not truly representative of your population. And then there are these underlying fairness issues and missed opportunity issues as well. So a solution could be that we take these underrepresented groups, which are there in very small numbers in our sample, and augment them by adding synthetic data. And augmenting these groups with synthetic data will create greater numbers of them in our sample and reduce the bias. And that leads us to a related area of reject inferencing. Uh, Reject inferencing is the process which we undertake uh, to make sure the rejected population is represented in our model development sample. And traditionally the techniques we use are we often take the rejected population and go to the bureau and get their performance from there and then include that in our modeling sample. There are other techniques also which do not involve going to the bureau, like data parceling, where a model built on the accepted population which funded is used to then try to predict performance on the rejected population. And there are many other techniques as well. Um, but synthetic data can be an alternative to bureau augmentation or data parceling. We are doing our experiments on this and will bring a webinar on using synthetic data in the area of reject inferencing to you sometime soon later this year. Let us now talk about cost savings. So we all know how expensive bureau data is. So now you go about building a scorecard. So you have to acquire historical append bureau data for your sample build going back how many more years you might have. So you have to do that. Then bureau performance data is also needed for the non-founded sample you are using for reject inferencing. Uh, and all these add up and it becomes an expensive proposition. So what if, say, we just cut the bureau sample by say 25% and instead use synthetic data for 25% of the sample instead of real data, and we have seen the performance doesn't change, and using this we can then have lower costs of the building the scorecard. And not only does this allow us to build the models at a lower cost, but that means since they are cheaper to build, we can build them more often and be more up to date in our analytics process. Let us now briefly talk about privacy and data security. AI generated synthetic data can help a lot with privacy and data security. We have not today discussed in details the techniques and tests we use to determine whether the synthetic data is good. Again, I will refer you to our previous webinars recording for that. But one of the key things we look for is it preserves the population's characteristics, and there are tests for that. And a second thing we want to ensure is that the seed sample that was used to generate the synthetic data cannot be reverse engineered and the identity of the actual records be unscrambled. Now, because both these steps are undertaken, that the sample is anonymous, is synthetic, but it preserves the population's characteristics. Therefore, it is very useful in performing exploratory analysis or portfolio level analysis and understanding the key characteristics of our customer base without worrying about data security issues or violating customer consent. And it has a lot of applications where you need not expose real data uh, to a larger group. You want to try a new technique with a new vendor or a new software, you can test it out with synthetic data and not have to worry about consent and privacy and data breach. You can allow this data to leave your firewalls, and within your firewall too, you can have different levels of access possible without killing the learning process within your organization. Let us now briefly talk about model performance monitoring. AI and synthetic data can play a significant role in model performance monitoring, documentation, and validation. So one of the things which I have often been asked by regulators and is a common requirement for a good model is that there is scenario testing done, uh, different scenarios which might come up. And the challenge often faced is that there isn't enough data for those scenarios to see how the model will do under them. And synthetic data can be generated and to help with this and enable scenario testing which ensures that our models are robust to these situations. Now, another big uh, concern is bias, and we have already covered it, that in the development stage we can reduce bias by using synthetic data. But this can, when we are monitoring the model, that same process can be extended, and this testing can be undertaken that, okay, for these underrepresented groups or regions or segments, is there an inherent bias in the model? So all that can be tested. And if the bias creeps in, it might not originally be there, and it might creep in over time, and in which case we can remedy that. And then there is this whole area of general documentation process we need for the model monitoring and validation and regulatory compliance. And over here, I know of several organizations who are experimenting with large language models to help with the process. No, not so much writing the document, though that's helpful too, but in just being able to catalog across the elaborate exercise that is taken whenever a model like this, or rather a system of models like this, is put in place. Uh, we are working on a comprehensive webinar on this topic as well. We are ourselves doing a lot of experiments in this area as well. and we will bring that to you too later in the year. That concludes our presentation today. Thank you so much for joining us. We will now open up for questions and answers, and please sign up for our next event if you found this session to be useful.